sklearnpreprocessingOrdinalEncoder. Description: the ordinal encoder transforms categorical features into numerical features by assigning a unique integer to each category. It is a simple and commonly used preprocessing step for machine learning models that require numerical inputs. Inputs: X a 2D array-like object, where each row represents a data sample and each column represents a feature. The input data should contain categorical features that need to be encoded. Categories: a list of categories for each feature, where each list item corresponds to a column in the input data. If not provided, the encoder will infer categories from the input data. Outputs: transformed data: a 2D array-like object containing the encoded numerical values. The transformed data will have the same shape as the input data, but the categorical features will be replaced with their corresponding integer representations. Categories: an array containing the categories learned during fitting. Steps: fit: the encoder learns the unique categories present in the input data. If categories are provided, the encoder uses those instead of inferring them from the data. Transform: the encoder assigns integer values to each category based on the order they were encountered during fitting. Metrics: none. Visualization plots: none. Fine-tune parameters: handle unknown determines how the encoder handles unknown categories during transformation. Use encoded value assigns the maximum integer value 1 to unknown categories, while error raises an error. D-type: the data type of the encoded output. Uncertainty methods: none. Challenges and fixes: challenge 1: the order in which categories are encountered during fitting affects the integer assigned to each category. Sample use case: if the encoder is trained on a dataset where blue is encountered before red, then blue will be assigned the integer 0 and red will be assigned 1. If a new dataset with a different order of categories is used for transformation, red may be assigned 0 and blue 1, leading to unexpected results. Fixes: ensure that the order of categories in the training and test datasets is consistent. Consider using a more sophisticated encoding scheme, such as one-hot encoding, that is less sensitive to the order of categories. Challenge 2: the encoder cannot handle unknown categories during transformation if handle unknown is set to error. Sample use case: if a new category green is encountered during transformation, the encoder will raise an error. Fixes: set handle unknown to use encoded value to allow the encoder to handle unknown categories. Ensure that the data used for transformation contains only categories encountered during fitting. Challenge 3: the encoder does not handle missing values. Sample use case: if a data sample contains a missing value in a categorical feature, the encoder will raise an error. Fixes: impute missing values before using the encoder. Consider using a different encoding scheme, such as one-hot encoding, that can handle missing values more gracefully.